Welcome everyone to the Open webinars. Today is August 13th, 2013. Glad to have you all here. We had a case that was kind of interesting. In fact, two of them with basically a RAID controller just dying, failing, and also volumes that from the array also failed, whether due because multiple disks have failed on a RAID 5, and subsequently, obviously, it's a disaster. And hopefully you did or have using the auto failover, either the active or the active passive. So this is what is all about and what you do when a case like this, when your RAID controller fails an auto failover, losing your volumes, your array, everything. So what we're going to basically go over, because it's necessary to understand how the procedure works, is we're going to verify the remote node has the resources. We're going to show that, and the volumes that are in the source mode. Then we're going to repair the server's new RAID controller and put the volumes back in and set them up for replication. So let's go ahead and start demonstrating this. What we'll do is first show you that I have two DSSs. Obviously what you're seeing right now is the surviving DSS. And I named them, by the way. If you look at the tabs here, Node A, and then of course the one that survived, which is now running in the active setup, is now Node B, and it's running in degraded mode. So all that degraded means is that its partner, which would be Node A, has lost its communication. So if we look here, we still have the resources. If you look at the local node, which is the Node B, the resources status is active. And so, but the synchronization replication state is not. So it's not synced, it's inactive, and therefore it's due because we lost the array and volume from the RAID controller on Node A. So B took all over resources as it should, and this is how it's designed. If we look, we still have our ping node status. Two of them are reachable. The auxiliaries, well, obviously the Node A is lost its configuration, so therefore it's going to report 0 back, or Node B is going to report 0 due to because of A's inability to be set up, due to because the configuration was on that array. So we have the auxiliary paths. You see that I have two of the auxiliaries here. I'm on the local node, which is Node B, and if you look at this 1.221, which is also up here in the tab where I'm locating for Node B. As we scroll down, we see that the ping nodes on Node B are reachable, and if we continue, you could see that it took over the resources for the scuzzy resources. So it is stating a replication task error for obvious reasons. Node A is no longer a valid replication sister have you. Now, we are still seeing the virtual IP addresses. So if you look here, I have the virtual IP addresses here of the last two octets, 10.10, 13.13, 11.11, and 12.12. If we ping them, so we see that these virtual IP addresses are still running. You're still sending data, so you don't have any downtime, and this is really good. If you see, so we have all the. Let's look at the 11.11, which is the other virtual IP address that is established between both DSSs during the time of setup, and you can see that we're still able to communicate and be able to send data on the Node B, which is now really the active server. So what do? Well, what we have to do, and this is part of the demonstration to help the engineers out there that do have a situation like this, which is very drastic, is to be able to demonstrate. Here on Node A, I have an LSI RAID controller, so I use the Mega RAID storage manager. So I try to simulate this as close as possible. I had a RAID 5 configuration. And what happened was I used the Mega RAID storage manager, and I basically deleted the volume and the array from the MSM, and bingo, what happened is the DSS Node A completely shut down, as it should, because you have it configured that way. So when you lose the array, which happens to some controllers, or the array is bad due to because you lost 2 or 3 disks or more on let's say a RAID 5, or if there was a RAID 6, and we've seen this happen because of the MTBS, mean time between failures of drives. So you've lost your array, you refix it, you rebuild it, and then once you rebuild it, now you're able to go ahead and let your new array in the unit manager to go ahead and start applying it. So let's build it. Looks like somebody is saying they're not able to hear me. Just want to make sure if that's true. Let's see. Give me 1 second, everybody. I want to make sure everybody gets on. This is over the voice over IP. So hopefully everybody can jump on and listen through, just turning on your speakers. So maybe hopefully they can get to listen to all this because it's going to be important. Also, this will be recorded and put on our website as well. All right, so let me tell them to turn on the speakers. So now I've got my new volume. So basically we're going to go ahead and create our new scuzzy volumes on the node A. So if we look at node B, and let's get out of the failover service. So we're going to go to Configuration, Volume Manager, and Volume Groups. Here you see the existing volume group that has the replication status for the scuzzy volumes. The two volumes that I am demonstrating this with is LV000 and 001. I made them very small in size because what I'm trying to demonstrate to replicate, if I went any larger, obviously it doesn't allow for webinar time to be able to work with the synchronization. So where we have to go now is to be able to build the scuzzy logical volumes on node A. So here we're going to go right into the volume manager and let's create our new scuzzy volumes. So we want to be able to use the volume replication and we want to create the same size. So we're going to need 2 of them. And what we're going to do is then re-replicate them. So here's the first one and let's do the second one. Select use volume replication. And we want to be able to match the same size. If there's a mismatch in size, they will not replicate. Also, you want to make sure that you don't use the volume replication. Looks like I did the NAS. Profuse apologies. Here, let's kill that. And we'll go ahead and create the second scuzzy volume. So when I do, by the way, it's actually good that we did do that so that we could show you the difference on the block I/O and the file I/O. So here if I create new scuzzy volume, you want to make sure that when you select the volume replication that you're replicating block I/O to block I/O. You can't replicate a file I/O to a block I/O. So just little information that will help you. It won't be able to replicate. You'll get some error message to that. Alright, so new scuzzy. Use volume replication, block I/O, and of course setting the same size. Now if you notice I didn't create the target immediately. This is because I like to make the same settings as on node B so that way you'll save steps, and I'll show you why as we go down the path. So here I have my replication status enabled for the 2 scuzzy volumes. Let's go to volume replication right here on the left. By default, when you set a volume into replication, they will be in source. Here, we already have a node B in replication. These are already set in source. So what we want to make sure is that on node A, we want to set them for destination because right now, all the current data is residing on node B, which is the source. If you notice, these are grayed out. That is because I can't make any modifications to it yet, and we're going to go into that. So here we want to set on node A on the new volumes to apply and set those for destination. Because these are brand new volumes, we're going to have to replicate the data from node B to A. Now on node B, if you notice, yes, you will still have your tasks, and they're going to stay running at this time, but nothing's really being replicated. If we stop the task, and let's let it stop, and we try to restart it, what you're going to find out is that there's really not going to be any data to restart because of the metadata. And now what I'm showing you is what you need to do is to delete the task. So you're not deleting the data from node B, which is now the source volumes. So even if you let this run and you assume that the task is starting and working, and you think, wow, okay, great, I got data replication and it's working and I don't have to do anything more, you're going to find that it's just not able to do it. So what you have to do is to stop the tasks, and once you stop the task, then you need to disconnect. So what we want to disconnect is the host binding. So here, if we go to node A, you want to disconnect, then go back to node B, and you will get some errors on this. There's some updates that we are going to be doing to be able to stop the replication and be able to give you a configuration file that'll send over to the new node B, A once you configure the volumes. So what you're going to run into is this fighting concept, because it's struggling to, and you're going to see some of the errors coming up that you're seeing, the reverse errors. It cannot bind to the destination, error 25. So disregard this. What you want to do is basically remove these tasks. So here, we're going to go ahead on node B is to clear the metadata. Okay, so let's give that a second. And let's go back to node A. And you can see none of the tasks have been pushed over. Okay. And I like to clear the destination so it's not getting any information from the previous task on node B that it pushed over. So when you click on any of the play buttons here, what you're going to get is the same situation. So let's let that run. And we've hit apply on that, so we've already done that. Now what we're going to do is let this sit for about a minute. So it's going to cycle out. So what we're going to do is create our scuzzy targets, and we're going to match it, and we're going to come back to this. Okay, so you can see that you're starting to get event messages coming right up. Alright, so try disconnect again. And then now let's go into B to set up the targets, to match the targets from B to A. So we're going to go to scuzzy targets. And we're working with target 0 and 1. Now at this point in time, you will need to, when you do this, the reason why I'm bringing this is that if you notice, you cannot detach it from the target. And this is due to because the failover is active. And also the reason why you could not detach as well from the volume replication. And that's what I want to demonstrate is that if you're starting to fight all this, it's because of one area. If you go to setup failover, you see that the replication is degraded. So you have to stop the volume, the auto failover. And when you do this, yes, your virtual IP addresses will be shut down. So it's best to go ahead for any of your initiators, your virtual machines, to go ahead and shut them down, because you're going to have to need a maintenance window. Now in the future releases coming out, we will have the ability to be able to add a new fresh source node, like another node A, like what you're seeing here, and be able to provide a configuration file. So our engineers are developing a very unique process to this. So we're going to have to stop the failover manager right now. And once you do this, then you'll be able to go ahead and detach the target, from the LUN from the target, to be able to copy any of the scuzzy IDs. So now we're able to start. Now let's go back into the volume replication on the node B. And you see your tasker there, and we'll disconnect. Okay, so now you see the tasks are gone. You can also see in the scuzzy target manager, you now are able to detach a target, a LUN, the scuzzy volume from the target. So when you box yourself in, you're trying to figure out where to go, you want to stop the failover service. Keep in mind to power down your virtual machines, disconnect your initiators, and know that you're going to be having some downtime. Okay, So at this point, what we want to be able to do is go back into our configuration volume replication, and we want to be able to take our current data that's on the node B source and be able to replicate that data to node B. So what we're going to do is have our dedicated, and I'm using a 10 gig eNIC that's dedicated for the volume replication. So no other traffic's on this other than the volume replication. So I'm pointing this to node A, and you want to keep the same password that the node A had previously, or you really don't want to change. You want to keep them the same. If they're node B has a different password and node A, just keep them that way. If you change them in the future and you disconnect for some reason, you can't figure it out, you really don't want to be fighting that. So try to remember that in your information and log information for the setup on your DSSs. So here we're going to go with, we're going to set up for volume replication. So vrep, we can really name it anything we want, even change it if you want. So we're going to go vrep for, actually let's make it 0 because I like to be consistent. So LV00 for volume replication 0. Since I'm using a 10 gig E, I'm going to use the bandwidth for the sync source at 600 megs. So we're going to create the first one. We'll go ahead and get him played and started. And what you want to see is this right here. So that will now start the replication path. So here on the second one, call him v_rep1 and set him for 600. Now we're going to verify if these are synchronized and consistent on both ends. So we'll go ahead and force the play on this one, and you'll see the reason why I set them kind of small to simulate it. If they're larger, you're going to need some more time because you're synchronizing from the beginning as if you first set it up, because there's no data on the node A. So what we want to do is check for status task. And here the vrep_0, we see that it's consistent and consistent. And let's look at v_1, it's consistent and consistent. So that's good. So now once this is done and they are consistent, what you can do is to go back to the volume replication. Okay, and you see that we want to be able to use the active. So I'm going to need one set for source and one set for destination. In the previous configuration, when I first started out on node B, LV000 was set for destination and node A was source. So what I'm going to have to do is stop the task and remove the task, because now the data has been synchronized to node A. Set him to destination. Now go to node A, and I need to set LV000 to source. And then create the task. And of course I'll set it to 600. So now what we're doing is setting up the proper way to do the active. So this helps with the load balancing performance values that we have set up with the V7 series. So here we're going to start the task. And let's verify the status. And what we're looking for again is to be that they are consistent on the source and destination to be consistent. Now we're completed. And if you look at for the node B, you could see that it's locked down with the gray mark. You cannot change anything. And so we're done. So the volume replication piece is completed. Now we can go into the configuration scuzzy target manager under node B and go to the targets. We'll start with target 0. Now I like a good naming convention. If I look at target 0, I named it on the bottom down here. You'll see it. I like to be consistent with my naming convention. if you notice, I have the IQN 2013-04 and then the colon node-A target 0. This is telling me that node A owns this on source level. If you remember, this is really for LV00, and the node B is the destination volume, but really the source is on node A. So what we want to do is keep our same naming convention for the new target for LV000. So we're going to name it to node A. Now, once it creates the new target on the left, you'll see it under target 0. You'll see that we have the same target name, and that's what you want right up here. Now, what we have is this volume here. We want to make sure that the scuzzy ID is same. So what I want to demonstrate to you, sometimes in a case you might have this, it may more, sometimes you may not, but I try to make it happen where you could have this event so you understand what's going on. If you got to have the same scuzzy IDs for the targets when you replicate, especially for active passive and active active, you're going to need it or it will not work. What we want to do is copy that scuzzy ID, go to the node A, to this volume here, LV00, and paste it so that the scuzzy ID is the same, and then click the attach. If you get a message that states that this scuzzy ID has already been named this, and you've tried, what you'll have to do is go back to node B, detach it, then copy node A's scuzzy ID over back to node B, and you eliminate that message. What's happening is sometimes it'll hold on to the same values and will not flush it out in some instances depending upon the older versions. So keep that in mind if you run into that issue. Now we go into the node B target, and here if we scroll down on the second target that we're working with, I have it named IQN 2013-04 node B target 1. What we want to do is we want to copy this over to node A, because if you remember, LV0001 on node B is the source volume. So we'll go to node A, go to targets, and we'll create our new target, take off the default, and apply the node B target name. So that way it helps you identify who owns what. So you know that on A, that target name, when you look at it, it's telling me that this is node B's source volume. And it's really good to know, especially for troubleshooting, or if you need to be able to know where certain volumes are and who owns them. It's just valuable and saves you a lot of hunting time. So I'll just copy the scuzzy ID from node B on that target 1, and we'll go ahead and paste it on the node A. And I like to always check before I continue to the failover setup process. So this way it gives you a sanity check more or less. So I usually put my eye up here. I usually see, okay, I got target 1, and I usually put my eye on the last 3 or 4 characters, so it shows me V8V. So if I go over to node B, I see that I'm node B, target 1, and I see the scuzzy ID being V8V. And then I check for the target 0 once more, see node A target, and KVP, if you have, you will. Just grab those and just put them in memory. And let's go to target 0. We see that it's node A right up here, and KVP is our scuzzy ID. Now we're done. So here what we want to do is now we're ready for the failover setup. In node B we can go right into setup failover, and let's go ahead and go to node A as well, get everything teed up. We go back to node B, and here we'll go ahead and start. If you notice, the auxiliary path, the other auxiliary path has been taken out, so we need to add that. So what we're going to do is I like to use the auxiliary path of the GUI access NIC. There's less traffic on it. It's just more of what the support engineers have seen to work better. So here I'm just going to notice that it's the third octet, and the fourth octet on E0 is 1.221. Well, that's how I'm connecting up here. If you look at my tab up under Firefox, I've got 1.221. So let's go ahead and add them. And now we're ready to add our new ping nodes. Typically you want to really get up to 3 ping nodes. So I'm going to add just probably 2 to shorten up the session. But you want to look at being able to get more than 2 ping nodes. So here we'll just, I'm even using, this is to one of my VMware servers. That's a good ping node. So we'll add another VMware server I have. 192.168.1.230. And of course, you probably want to add a third one. So we're just going to keep moving here, but I just want to make that note. I like the defaults. Again, if we have a trigger, any I/O errors on any volume, that is probably worth having to set the defaults. Some engineers like to on specific volumes of the array. I want to know if that array controller has a problem, and I need to take this system down. And if there is a problem similar to what I simulated, that server better drop down so I can approach it and diagnose the problem as quickly as possible. I don't want it restarting, and that's what it's designed to, is to shut down so you can immediately, because if you start restarting, you don't know if you're going to be having some engineer who forgot, he wants to start re-replicating, and of course you can have some issues. Now let's go right into the scuzzy resource section. Here we're going to add targets. Obviously, I'm going to be able to take the node B target one, which is on node B, and he's going to own this resources. So let's just go ahead and apply him. And I'm going to go over to node A and scroll down. Also, you notice the updates for the auxiliary path has been done. The ping nodes has been done. Here we're going to go to the scuzzy resources. And we're going to add node A's target into its resources. So here's node A. It's the only one that's viable that we have. And if we go back to node B, you can see its resources. And if you're looking to find out who owns what resources, right here under the resource pool, you'll see local node, and below that, remote node. Right here. So let's go back to node A. You see that node A's local resources are now applied, so the target is in there. If we go to B, even on node A, on the remote node, you can see its target, it now owns its resources in node B. Now we go to the virtual IP address. Here, I like using MPIO, so what I'm going to do is I have 2 of my 1 gig NICs, so it'll be ETH2 and 4. So I'm going to start creating my virtual IP addresses that I had previously. And I'm going to be using ETH2. And add that. Then I'm going to go on node B and add the virtual IP address for its local resources, which you're seeing here. And I like to do it making sure that they're balanced. So we're using ETH2, and we used ETH2 on node A. Now we need to use ETH2 on node B. So here we're going to use 192.168. And the last one was 10, so we're going to go 11.11. ETH2. And ETH2 on node A. And of course, 24 bits on our subnet. Now, you see already, I'm going to let this finish out. And then you'll see both of the virtual IP addresses completed for the first set. So I'm going to have 2 more virtual IP addresses for ETH4. So here you can see on node B, I've already set the virtual IP address and already updated for node A. Now we'll go back to node A. You don't have to do this. You can actually do this right on one node and it'll replicate it, but I like to be consistent. That way I can be busy, lose track of mind. We're going to add the other virtual IP address. And this is going to be for ETH4. So I'm going to go, let's see, 192.168.12.12 ETH4. And then on the remote node, ETH4. And here I'll even do it on this side just to show you don't have to flip back and forth. It's just more of my habit. You could do it the way I'm going to show you right now. You could just stay on one node and enter the virtual IP addresses for each of the Ethernet NICs, what we call the storage access NICs. So the virtual IP address is sitting on top of those storage access NICs. and that they're being established between the active-active or the active-passive auto failover. So here we'll add it here. So we're at the 13.13, and that would be ETH4 and ETH4. Now, so this gives me, for multipathing, really, you can use bonds. We do have some documentations on recommending some bond types. I'm more of inclined from what we see in the support industry to like to look at using the multipathing. We find that you're getting multiple streams versus a bond, which is one stream. So this is the reason why we have multiple virtual IP addresses. So this is where I have them. They are all set now for each of the NICs. You see 11.11, 13.13, 12.12, and 10.10. We're done. So right now we're ready to fire up the auto failover. Let's go ahead and click it. Now what's happening is this is going to take about a few seconds. So while this is starting up, there's a lot going on. It's validating that there is the replication that's finishing. It's going to validate the syncs are completed, so the volume replication are synchronized, they're consistent. It's going through a lot of checks right now. And it's also going to be checking the resource pools. Are they validated? Are the target names the same? Are the scuzzy IDs the same? The LUN numbers are the same, and they're going to match. It'll even match any inconsistencies if there's a bit off. If you can see the readings are approaching now, they're seeing the ping nodes that are addressed for both sides. They're validating that. They're also validating just right now that the auxiliary paths are working. So it's verifying all these checks and balances. And here you can see once it's completed and the proper resources, that the auto failover service has completed all its checks and balances, and you're ready to go. So let's verify right now. We'll bring up our DOS prompt, and give me a second, and we'll go ahead and test our virtual IP addresses. Start off with 10. We see 10 is live, so we're ready to go ahead and use 10. 11's live, so we can use 11. Pull back into our initiators now, and now we're up to, oops, I just did 10. Let's go to 12. 12's up. We're good there. And 13.13. We're live. So now we can go ahead and reconnect our initiators and start up our virtual machines, and you're good to go. In the future release, we are going to come up with a really neat convention. We're on a Node A. If you look what we just demonstrated, if you lost your array, that we will have a configuration file that will be saved either on both nodes. So if this event happens, you will be able to upload the configuration. We will be talking about it, providing webinars. Engineers have been working on this for many months, so it's going to be very nice to have this. This is also similar if you're going to lose a motherboard or a critical component such as the RAID array or your volume. Well, thanks everybody. I hope this helps many of you engineers. When you get into something that's drastic of losing your volumes in your array, it is sad when it does happen, but we have seen it. In the meantime, please check out our webinars that are always located under support, webcasts, and videos. And here we have a plethora of information. Also our knowledge base articles on the left, you'll see white papers, how-to resources, and just much more. Take care everyone. Bye-bye.